Welcome everybody. Thank you for attending this webinar on forging a cybersecurity defense for utilities. This webinar will be presented by Jason Christopher from Dragos and Michael Meeson from the Western Farmers Electric Cooperative. And this is the second webinar in our fall series of the Digitalization and Cybersecurity webinars. My name is Johanna Kolomans-Weinen. I'm the Senior Program Coordinator at the United States Energy Association, USEA. I'm on the Energy Utility Partnership Program based in Washington, D.C. Please note that this webinar is being recorded and all participants are muted, except for the presenters, of course. With their video turned off, you're welcome and you're indeed encouraged to post questions either in the chat or in the Q&A. My colleague Jake Swanson and I will be monitoring them and we'll pass them on to our presenters as appropriate. So to give a brief background on USEA, for those of you joining us for the first time, we're a nonprofit membership association of public and private energy-related organizations, corporations, and government agencies. USEA represents the broad interests of the U.S. energy sector by increasing understanding of energy issues both domestically and internationally through capacity building activities and events like this one. This series of webinars is financed through our cooperative agreement with USAID, the Energy Utility Partnership Program, as I mentioned, and in particular through USAID's Bureau for Economic Growth, Education, and Environment, E3. Today, our presenters will share with us key elements of organizing cybersecurity strategy and tips on how utilities can develop their cybersecurity strategies. This is a 7th webinar in our series. We had 5 earlier this year, and then they're starting with the next series now. You can find recordings of past webinars on our website, usea.org, and then you go to events, and if you scroll down, then you get past events. And there you can click on these icons that you see here and get the past recordings. Please join us in the coming weeks as we cover other areas of cybersecurity of importance to all of you working to strengthen the security and reliability of electric utilities. Next, Kristen Madler, Senior Energy Officer at USAID, will make some brief comments.
Thank you, Johanna, and thank you to USEA for your work in organizing today's webinar. My name is Kristen Madler, and I work in USAID's Global Energy and Infrastructure Office. And following this webinar series featuring leading US and international digitalization and cybersecurity experts, USAID's Global Energy Division will launch a new business innovation partnership program. And this program will support utilities' ability to adapt to innovations in technology, increasing customer expectations, changing government oversight, and encourage new business models and business process improvements. The program will entail 3 components: change management and certification, building technical leadership and capacity, and advancing innovation efforts. And the partnership will build on this initial webinar series by inviting select utilities to participate in a high-level workshop on innovation and nominate employees to join a more formal 1-year program with an emphasis on utility change management and innovation. In today's webinar, our presenters will discuss the key elements of a cybersecurity strategy and walk us through the process of developing a utility cybersecurity strategy. So I would like to thank our speakers for joining us here today, and I will pass the floor back to Johanna to formally introduce them.
Thank you, Kristen. So as I mentioned, our speakers are Jason Christopher and Michael Meeson. Jason Christopher is a Principal Cyber Risk Advisor at the industrial cybersecurity company Dragos, where he blends innovative approaches for risk management with state-of-the-art technology and services across the company's product catalog. With over 15 years of experience in cybersecurity and industrial control systems, Jason offers critical infrastructure expertise in developing successful cyber risk strategies. Prior to Dragos, Jason held multiple roles in industry as an executive leader, researcher, regulator, and engineer at companies including Axio, where he was CTO, Chief Technology Officer, and EPRI, where he led security metrics research and development. Mr. Christopher also spearheaded the energy sector strategy for the National Institute of Standards and Technology, NIST, cybersecurity framework, and the cybersecurity capability maturity model, C2M2, that we discussed last week, and was a technical lead for the North American Electric Reliability Corporation, NERC, Critical Infrastructure Protection, CIP standards. Michael Meeson, Senior Manager, Information and Security, began his career at Western Farmers Electric Cooperative in 2009 as a Senior Network Engineer, and has also served as Manager of Technical Services there. Before that, he worked on enterprise information technology and cybersecurity in the financial services sector. His areas of influence include information technology, operational technology, telecommunications engineering, network engineering operations, and cybersecurity. So I'm going to hand the screen share over to Jason.
All right, thank you. All right, hopefully everybody can see my screen. Always a good first screen test. So thank you very much for that introduction. I'm always sort of nervous introducing myself. I'm not really sure what parts of my resume people want to listen about. But what we're going to talk about today is really where I spent a bulk part of my career, which was going through standardization for utilities in particular on cybersecurity concepts. And sort of building those out based off of cybersecurity standards that are already out there, which I know the next few iterations of this webinar series will cover. So hopefully this will be a good background as folks get ramped into what's going to happen on the 17th and 24th coming up. And then Michael will then sort of tail off from there and be able to discuss a lot more of the in-depth utility practices that he's been able to deploy within Western Farmers. So I'm looking forward to the conversation, and definitely as folks get questions and think through them, and we'll have that Q&A at the end, I'm looking forward to seeing everyone's perspective on this problem. What we're going to do throughout this is really talk about this in terms of a programmatic approach. There's a lot of reactive things that happen in cybersecurity, and this idea of what we're talking about with forging a cybersecurity program. You can see here, I've got a ladle full of forged metals that we're going to be working with throughout this presentation to really make sure that there are a programmatic approach or a vision as we put forward new security controls. Before we get there, though, what I'd like to spend a little bit of time with, sort of what are we discussing when we think of the impacts themselves? We are thinking through industrial technologies, what we may call industrial control systems, ICS, or operational technology, OT. In this case here, what we're really talking about are the things that are impacted in the physical world, where a 0 or a 1 is not a credit card number, it's not billing information, it's something that will power the grid in this case. But you will also note that a lot of those OT and ICS technologies are used in multiple sectors. The devices themselves may be the same, what they control may be different. So where we're talking about maybe switches that will impact the reliability, right? We'll actually open up a switch and then we won't have power in a certain area. We may be able to turn off a turbine, a generation station. That same sort of element that controls it, that transfers that 0 or 1 into that physical opening of something, is also used in manufacturing. It's used in oil and natural gas. It's used in conveyor belts that we may have in food and beverage. All of these technologies sort of share that same DNA, but the impact will be different. And that's what we'll dive into a little bit first. When we talk about them, we know that they're different than IT, traditional information technology. The operations in this case are 24/7 by forever, right? They always need to be operational if we're going to have power. From them to be on is when we're going to have that reliable state that we're expecting. And the lifespan is completely different. I get a new phone now, every few years tops, whereas these are talking about things that are on the scale of decades, right? That we are not able to replace these things, and therefore things like looking at what technologies may be deployed, we're dealing with threats that may have been decades old when they were created versus what we're facing today. And in the United States, we define them across 16 critical infrastructures, though understanding the international audience here, that may be different. I know that Europe and other countries have defined those sectors a little bit differently, but overall it's the same idea. 0s and 1s transform into physical something. And so what are these systems themselves? Again, think about that physical processy. When we're thinking about motors or controllers or sensors that may be out there, our safety systems are a good example. Anything that receives an input and that output is going to be that physical piece that we're worried about. And over time, we've actually started connecting these more and more. We did this for optimization purposes. You can see here that we talked about it in the very sort of nascent early stages where we had a conveyor belt maybe being managed by a person. In this case, maybe we're talking about more manual operations when we think about the grid and what utilities are working through, to then starting getting wide area control. So we may be talking about our SCADA systems in this case, or if you're at a plant, our distributed control systems, where we're getting more visibility into the process itself before finally getting into this sort of highly connected state where we're headed to right now, really, where we start seeing more information technology like things in our OT environments. We start seeing more sort of IT protocols. We see more IT devices, but then that data is also going somewhere else. It may be going to a vendor for maintenance purposes. It may be going somewhere for business purposes or billing purposes. And unfortunately, as we add in those sort of IT-centric technologies, the same security approach won't apply for OT. You can see here, I've got a list of 5 or so IT best security practices: encryption, patching, antivirus, vulnerability scanning, active vulnerability scanning, endpoint agents. None of these are applicable in a lot of cases to the OT environments that we protect. If we run, for example, vulnerability scanning, we may actually accidentally crash the entire reliability of the system that we're trying to protect. When we think about antivirus, it's only giving you sort of that endpoint of one tiny little sliver of the entire system. Patching, you may have operational outages. You may need to wait for a maintenance cycle, for example. So a lot of these technologies that we expect to see in the traditional IT arena won't be able to be applied to our OT strategies. And so already this is erecting this idea of, if we have a cybersecurity strategy, we need to be able to be mindful of our environments and understand what works and what won't work based off of what we're trying to protect. And unfortunately, we have had incidents that have impacted these OT industrial systems. Now, again, while you may look at some of the events that are listed here, and you can Google any of these, there's a lot of information about ICS and OT attacks. When you go through them, you may say, well, what does the loss of control at a furnace have to do with the utility? In those cases, again, remember that the DNA of those systems, the industrial control system itself, that programmable logical controller, the remote terminal unit, the terms you may hear when people are talking about OT systems, they're the same in all of these sectors. Every single one of these has the same DNA. It's just what they control may be different. So if you see an outage that may happen in an industrial system in another sector, what that outage looks like could be very similar to what you do from a utility perspective, because they share that same underpinning of technology at the end of the day. And of course, the 2015 and 2016 power outages there are referencing the Ukraine outages, both version 1 and version 2, that have unfortunately happened focusing on OT. But what does that look like? What does this really mean when we say that OT side versus that IT side? You can see here we have the traditional, what we'd call the IT network, right? Our corporate IT network here. We've got some routers and different elements in place, databases, maybe some endpoints, servers, workstations, etc. And we would call that part of our stage 1. They're internet facing in some cases. They have email servers maybe. It's where we have a lot of our back office pieces, maybe our HR systems, billing systems, things of that nature. But then, and I'm using plant as an example of a generation facility. However, this could also be what you may do for wide area transmission or distribution. We would have what we'd expect to see on the OT side, which would be inclusive of maybe these programmable logical controllers that actually impact something in the physical world. And we refer to that as stage 2 of an ICS or a utility-based attack, where the attacker will use stage 1 as that first point of entry and then try to pivot into our more sensitive, our more impactful OT technologies. So again, when we talk about the strategy, I just wanted to be able to lightly frame us up a little bit as to where we may apply different technologies and approaches as a result. When an attacker is looking to go towards your OT systems, they're typically going for 3 different objectives: loss, denial, or manipulation. And that'll be for the view or control of the systems themselves, maybe even the safety systems or the sensors and instrumentation that you are depending on to do a reliable state of something within your own operations. So when an attacker is going through this, again, it's not a data breach. It's not trying to get credit card information. It's trying to deteriorate the reliability of the state of operations. It's now an engineering problem as well as a security problem. So again, operational impacts are going to be key. And when we think through the overall difficulty, again, we're going to look at attackers that are going to be a little bit more sophisticated than the average, let's say, what we affectionately call script kiddies, right? What we talk about attackers who may be looking for opportunistic attacks. While some of that may still happen, right? We talk about ransomware. Ransomware doesn't focus on OT, but it may compromise your security of the OT system. It may have a collateral effect where if your OT system is not segmented, is not separated out, then you may find yourself having an IT attack that sort of pilfers into OT accidentally, not focused on operations. If you want to have a successful attack where you're also going to talk about understanding the engineering process, understanding the control system itself, in that case, you're talking about a very well-educated attacker who understands control systems. And that attacker in that case is trying to blend things across IT security, OT specific protocols, the engineering process itself, as well as what you may do as a utility as part of incident response. And those are things that we actually saw, for example, in those Ukraine attack scenarios that impacted those utilities. But as I mentioned, there may be opportunistic attacks, things that are not focused on specifically what happens in OT, but they happen in IT, and because there are poor boundaries set up, it may trickle into OT. WannaCry did have a few impacts that went into OT because of sort of bad segmentation, bad understanding of the IT versus OT problem. In this case here, you can see how quickly it spread. This video is actually from the New York Times. I love this video because you can see we're measuring this on minutes. And in minutes, we are talking about having over 230 companies get impacted across their systems, impacting multiple thousands, if not hundreds of thousands of computers simultaneously. And we also sort of saw the same thing with NotPetya. NotPetya, I affectionately say not ransomware, right? It was definitely a wiper disguised as ransomware. But when you look at what it did, it impacted the operations, the actual industrial control systems of these companies. And it was an opportunistic attack, right? There's nothing that you would have seen as FedEx and Merck and Maersk all having sort of a same DNA of something. But they do when you talk about the OT side. And in this case there, we saw $10 billion plus in estimated damages worldwide, with over 2 million computers impacted within 2 hours. So even if you don't believe that your utility may be a target, which could be true, when you think about the overall sort of collateral impacts that may happen, having this defensive posture in place and the strategies that Michael and I are going to talk to you about is really a key part of just good hygiene to prevent these type of things from happening to you. And so that enters the ICS Security Crucible, as I've affectionately dubbed it. And in this case here, what we're going to talk about, just a little definitional time, the Crucible itself is going to be something that is defined as a new programmatic approach where we are blending a lot of things together with high volatility, high energy to be able to craft something new, create new weapons for us in this case. So we will be dealing with some very high temperatures, just as you would in a foundry. You're going to need a lot of focus and maybe some additional resources across the silos of engineering and operations to be able to help out with this. It's also going to talk about a lot of creation of something new, which may be uncomfortable as we build these things out. Something new is always a little bit uncomfortable. The key elements for this program that I'm going to talk about. We're going to start off with a discussion of what our metals are that we're going to use. So just thinking about anyone who's familiar with metallurgy, we're going to start off with bronze, and then we're going to upgrade ourselves to iron, and then lastly steel. And then we'll also sort of build out weapons and armor itself based off of all these metals. And I'll discuss each of these in turn when we get there, but let's start off at first with talking about the metals that we'll use. The metals themselves, we started off with bronze, in which case you will likely be originally constrained with resources. You may not have many people, you may not have a budget in place, there will be no documentation and therefore no lessons learned. And then we'll have a lot of discussions around sort of the heroes of your program. It's good to start off with heroes. The heroes of your program, they do the good things because it's the right thing to do. However, if they were in this case to win the lottery, right? So they get an instant win scratch off and they win millions of dollars. And despite really loving their job, they don't come back to work for the next day or week. Could you repeat what they do? If the answer is no, because they are so pivotal and there's no documentation, then you'll be bronze. As you build a budget, then we'll start working with iron. And then we'll be able to move across, different tribal knowledge and oral histories into something that's written down. And we'll start partnering with our engineers and with our IT corporate folks. And the resources will become less scarce just by DNA and just sort of making this program organic. And then steel sort of the end state of where we all want to be, where we know that our people are trained and ready. They have exercises. They're receiving sort of constant education about cybersecurity and OT and IT. And our executives are a critical part of that, right? So now all the way up to the CEO or equivalent level, the chief executive officer or equivalent. They're the ones who are saying, hey, these are the policies that we do because it's the right thing to do. And our capabilities are also double checked to make sure that they are actually efficient for what they're supposed to be doing. So with those metals, what are we going to create? What is our cyber arsenal, as it were? These metals themselves are sort of, again, designed to tell you relatively what strength of the weapon it is that we're going to have, but the weapons themselves will describe your program. And you can see here, this is a great Twitter account, Sun Tzu Cyber. Your enemy cares not that the maintainer of your internet connected server left 10 years ago. If they are in that conversation, then you may be more in bronze stage, right? So even sort of how do you idealize and talk through this programmatic stuff? It really needs to be something that is based off of where your resources are. The first weapon is a mace. It's going to be your initial sort of quick win, quick hit, which is understanding your systems, linking your industrial control systems to processes, systems, and devices, understanding what is high impact, what is no impact. Do I care about the building system as much as I care about the generator? Those probably should not be the same answer, right? Because the generator is actually relying on that power. And so understanding that is your first weapon that you'll sort of build out. Then that's segmenting and zoning. So actually understanding, now that I know what the sort of really big wins are, the generator, for example, maybe I should have that on its own network. I should have a firewall that is able to manage the communications back and forth. So if something happened from the IT side, it can't go into the generation side. To actually logging and monitoring, looking for badness, actually going through what we call hunting. If you're really, really mature, if you're in the steel stage of building your bow and arrow, that would be sort of hunting and actively looking for bad stuff. But to start, it could just be enabling logging. And then lastly, investing in sort of an incident response, understanding sort of what a bad day looks like. And in the very first step, that could be just a phone number of who to call, to automatically having a incident response team, very similar to how we do disaster recovery. If there was an earthquake or a hurricane or tornado in utilities, we are really good at being able to respond. But having that same capability in cybersecurity is a little bit more difficult. And so understanding what the right metal is for you, you really want to be able to start off with building a organic program around it, finding a champion, assessing where you are and being honest about that assessment, right? Make sure that you know where your weaknesses are so you can help build into a roadmap if you can be proactive with that. And understand what executive engagement looks like or who your heroes are, that if they won the lottery, how bad would this be for you? And then building out that roadmap once you understand where you want to be based off of that. And that could very simply look like this, where I have my 3 metals on one side of this sort of road mapping equation. I look at each and every piece of weapon that I want, right? From my assessing criticality, creating segments and zones, building out my monitoring program to having incident response, and assess Where are we? Are we bronze in certain areas? Are we iron in others? What would be our strengths or weaknesses here? And then find out where you want to be. Build out that roadmap. And if any of this looks or sounds familiar to you, it's because all 4 of these categories are already built into cybersecurity standards that you may be looking at. Identify, protect, detect, respond, and recover come out of the NIST cybersecurity framework. I know that that's also mapped directly to the C2M2, which you heard about last week. I'm sure you hear about again in the next couple of weeks. So all of these ideas are already in the requirements that you may already be looking at or are nervous about looking at because they look too big or too long. It really could be simple. It could just be these 4 buckets and understanding a little bit about where you are and where you want to go. We did all this using a maturity model. So those metals is crawl, walk, run, MIL 1, MIL 2, MIL 3, straight from C2M2. And so building that out allows us to redefine that sort of ICS Crucible as using standards and maturity models across our utility space with executive support. And that is really the crucible at the end of the day. And my only recommendation on when utilities ask me where to start, there are a lot of standards in this space. You're going to hear more about them next week and the week after. They all share similar language and conversations. Pick up whatever one makes the most sense to you. They're all great starting points. Some may be easier than others. In this case here, we started off with talking about the NIST cybersecurity framework, as well as the C2M2, the cybersecurity capability maturity model. Both of those could be very easy documents to start off with, which gives you sort of this idea of using the right tools for this job based off of assessing where you are and where you want to be. So now we've defined what the ICS Crucible is, right? We are now having a plan to create and sustain an ICS security program with governance, executive support, based on industry accepted standards. When you use a standard, you're accepting what your peers have already done, and that really does help you out in the long term. And I highly recommend for next steps, I always like to give people sort of where you should go next, and Michael will definitely be able to expand on these a lot more from his utility perspective. Find or be that initial champion. If it's not somebody that you can point to, and they could be anywhere, they could be in human resources, I've seen in many utilities, find it or be it, so that you can start banging the drum about what it is that you need within your security program. And create that roadmap if you can. I know that there's the reactive part of the job and the proactive part. This is the planning stage. And maybe this is only 10% of your job to start off with as you can build a roadmap as you have resources. It may be more difficult as you begin, but once you remove that initial friction, it should be easier. And then adopt those ICS standards where you can. This needs to be part of how we do business as a utility. Just like we provide reliability, we provide safety to our engineers. Security is now linked to both of those. It is both safety and reliability. And I'll leave you with one last sort of mantra of what could help you sort of define your program a little bit better. Prevention is ideal, but detection is a must. If you cannot prevent, you must be able to at least detect that an adversary is in your environment. But without response, detection will be of little value. So build out your program based off of sort of this hierarchy of understanding that you must be able to detect and you need to be able to have some sort of incident response in the case where your prevention fails. And before I pass it off to Michael, just a few notes that if there's any more information you'd like to have about threats or vulnerabilities or how ICS works, right on dragos.com, we have these reports for free. This is all the information that we sort of go through in a year in review, where we look back at what it is that we did from a vulnerability perspective, from tracking the threat and activity groups that are looking at industrial control systems, and what we do across our services arm to make sure that utilities are protected. So those are free. Highly recommend being able to read those if this topic is new to you or you want a refresher. And with that, Michael, I will pass it on to you.
Okay, thank you, Jason. Let me get my screen share. Okay, hopefully everyone can see my screen. Thanks again, Jason. I think Jason gave us some really good advice there. What I want to take an opportunity to do is to talk about some practical steps that as a utility you can take to begin forging your program. But I want to call back something that Jason brought up, and it's a very important point before we get started. And that is that whenever you look at OT security inside of utilities, a new approach is in order, right? We can't strictly look at what we do in IT security and emulate that, in that there are so many other considerations when you look at OT systems, industrial control systems, distributed control systems, that we simply they're simply different than in an IT environment, or they don't exist in an IT environment. So what I hope to do is to talk to you a little bit about, if you find yourself in a situation like I found myself, what do you do when you are the champion, or there is no program in place, right? You don't have a program, maybe you don't have executive support yet, but you still have requirements. The requirements to protect your assets and to ensure the operational integrity of your utility operations, those still exist. And so sometimes in the absence of this larger, more deliberate program that Jason described, we have to take a bottom-up approach to building those weapons and those armor. So that's what we're going to talk a little bit about today. So back to the theme of really practical steps. Step one is identify your objectives. Now, I'm sorry, I know that sounds very simple, but there's a lot of competing interest in utility operations, right? So what I typically do is I create 3 buckets of objectives. Operational objectives, what your utility operations need from your security organization, your security objectives, and your compliance or regulatory objectives. So those are the 3 major buckets. And when you start to think about those things in those buckets, it can bring some clarity to what's required. So my recommendation for the first step is start thinking through your objectives in these 3 different areas and documenting those objectives. And that's going to be important as we get into the later steps. As you start to develop capabilities and you start to build this program, you're going to be tying that back to your operational objectives, your security objectives, and your compliance or regulatory objectives. Step 2 is focus on architecture. So my experience has been that most of these industrial control systems or distributed control systems or any kind of ICS has typically been evolved over years and years. And that means that the network infrastructure and all the OT related equipment has also been involved. So we have a new requirement and we evolve that system to meet that requirement. We have a new regulation come out, so we tweak the system to make sure that we're compliant with that specific regulation. When that occurs, it's a little bit of a handicap for people who are trying to defend those systems. So many times I've had to start from the beginning and re-architect those systems to make sure that they are defensible, to make sure that they are purpose-built, and to take into consideration specific things. And I wanted to give an example of some specific considerations around architectures, where to encrypt or where not to encrypt. In IT security, we want to encrypt everything in transit, at rest, on access. We want to encrypt everything, right, to ensure that we have confidentiality of that data. That's not a foregone conclusion when it comes to industrial control systems. Perhaps you want to encrypt in places where you're transporting the data, but once it's inside the industrial control system, you probably don't want to encrypt that traffic, right? Because number one, it makes it impossible to monitor that traffic, and number 2, it may have an adverse impact on the reliability of that traffic. So that's a quick example of why you need to think through your architectures, and perhaps you need to re-architect your most critical systems so that they are defensible and that they are purpose-built. I can't say too much about how important the focus on architecture really is. It lays the foundation for all the other steps that you're going to take. The next step would be to gain network visibility. So the network traffic is one of the few things that you can trust. Yes, it's important to know what's happening on the clients and the endpoints in your networks, but nothing is as important as being able to monitor the network traffic, because it is it's almost like a trust anchor. It's very legitimate. You can trust what's going on the network if you can see it, but you have to do it in a way that doesn't have an adverse impact on the industrial control system. So passive visibility is key. That means you can monitor the traffic, you can run intrusion detection and monitor for specific threats, but you can't get in the way of that traffic. You can't manipulate that traffic in such a way that it has an adverse impact. So that's why passive visibility is key. But then once you gain that visibility, you will start to see a lot of noise on your networks, and that will get in the way of your monitoring as well. So we're going to talk about that in a moment. But the most important part of network visibility is the byproducts that you get from that. And three very important byproducts are listed here. Application data flows. So application data flows are this idea that you have to understand every binary that's operating, that is a critical part of your industrial control system. What is the source and destination of the traffic for that binary? What is the orientation of that traffic? So is it only outbound? Is that traffic two-way between two systems within your industrial control system? Or is it two-way with another system outside of your industrial control system? What are the source and destination ports? You have to have very good network visibility to be able to do that. So it's a key component to understanding your industrial control systems. Also, network protocol inventories. That's a byproduct of gaining visibility. So for instance, you may believe that you know all the protocols that are running inside of your network, but when you gain visibility to your network traffic, you may see that you have some unexpected protocols like IP version 6 or new protocols that are trying to bridge a gap between the new IT protocols and the old IT protocols. And if you allow those protocols to exist in your network when they're not being used, they're not required, that represents a significant risk to your industrial control systems. So a quick example, we found in several industrial control systems that Cisco routers can broadcast legacy calls that are meant to be sure that Cisco routers and switches are backward compatible with old technologies. There's some risk there. Those protocols, because they haven't been updated and they are legacy, those protocols are vulnerable. And so we would not have known that if we didn't have good network visibility. So application data flows, knowing every application that's happening in your environment, what it's talking to and how, a protocol of all the inventories that should be occurring on your network, those all lead into a meaningful system baseline. And a system baseline is multiple components, but essentially it gives you the ability to understand what normal looks like inside of your industrial control systems. So that's a key point for some of our later steps, is you have to know what should be occurring inside of your industrial control systems. I do want to touch on application data flows for a second. The first time that that I was involved with mapping application data flows inside of an industrial control system, I guessed that there were 10 to 12 important application data flows inside of that system. And what resulted was a diagram that came out that looked like this. It turns out there were almost 50 to 60 critical application data flows. I had no clue, and I thought I knew that system really well. And so what you see on the screen is it's a very busy example of what a full application data flow might look like. This diagram is set up so that you could click a button and say, I want to see every system that's communicating on a specific port, and all the other lines disappear, and you can see only the systems that are communicating on that port or to that from one system to another. So it's very important that you have knowledge of what are the critical application data flows. Don't assume that you know, because it's very risky. Okay, so the next step is to develop your capabilities. What do you need to do to sustain, and this ties back into your operational objectives and goes to the point, Jason's point of hygiene. What do you need to do to sustain your operational objectives, your security objectives, and your compliance objectives? So when we say develop capabilities, we don't mean deploy antivirus, right? Those are tools, those are weapons and armor, right? A capability would be more like, we want to do continuous monitoring on our industrial control systems. Continuous monitoring as a capability. We want to be able to do computer incident response for all of our industrial control systems. Incident response is a capability. We want to be able to do computer forensics. That's a capability. We need to be able to do network traffic analysis. That's a capability. These are all examples of capabilities. And then, of course, Jason brought up network threat hunting. Those are capabilities. Those are very high level things. Now, maybe we're going to have to go buy tools and create weapons and armor to flesh out these capabilities, but still we're at a planning stage where we're thinking about what do we need to do to sustain our objectives. So once you know what capabilities you're going to have in place, then, and I know this is counterintuitive, or it's not obvious, this is the point where you begin to staff your security operations. So my first note here is that you can't build a soccer team full of goalkeepers, right? So if you hire a bunch of people and then decide what your capabilities are, perhaps you don't have anyone that has the experience you need in those capabilities. So hire for the skills that you need based on the capabilities that you have defined. And of course, that's tied to your objectives. So you can see how this is a cascading effect. So you won't probably be able to find specific personnel with every skill that you need. So the next thing you're going to have to do, once you've started hiring based on the skills you need, you're going to have to create training roadmaps to fill in the gaps and be sure that your personnel have the right skills and the right training available to them to operate inside of those capabilities and to do the things that your utility needs them to do. Now, I get a lot of questions about what kind of people should we hire, because there's everyone who is in OT security is gainfully employed, and they've got 2 or 3 other companies waiting for them to change jobs because they would love to have them. So we have to build some of these security operations folks. And my advice is always to seek individuals that have broad IT knowledge, IT practitioners that have broad knowledge and understand the foundations and the fundamentals, and that they have most importantly, they have the aptitude to apply that knowledge in new ways. And then I remind everyone at the end of that conversation is there's not a system out there that you buy and you put in your network and you turn on the button and you hit the button and you say, okay, everything's secure, we're going to go home now. You have to remember the people secure these systems. People secure industrial control systems, not systems. Systems don't secure systems. Those are tools and armor that we use. Those are in the toolbox, but they are not the solution to security. They are tools that we use. Humans are the ones that secure these systems. So now that we have our personnel in place and we know what our objectives are and we know what our capabilities are and we're honing those capabilities and we're training up, my next step is focus on variance. So remember, we have these wonderful baselines. We have this understanding, the state of understanding about what are our systems doing, how do they act, what is the network traffic. Now we need to figure out how do we keep that secure. And I would say there's too many threats to these systems to name or even for most people to monitor. There are some out there that can do it, but most people lack the ability to monitor all the threats. And with the velocity of those threats, they're changing so quickly. There's new threats every minute of the day. It's very hard to keep up with all that. So my advice is look at your critical systems, your industrial control systems, and monitor them for change or variance, however you want to think about it. Change or variance inside of your industrial control system is a precursor to a threat. That is almost a surefire way to find threats. Now, maybe it's a misconfiguration that caused a vulnerability. So maybe it's not a threat from the outside, but because that misconfiguration caused a change and you identified that, then you were able to intercept a new threat and deal with it instead of letting it become exposed to an attacker. So I can't overstate, especially when you're beginning your program, how important it is to take this perspective on, I want to focus on how I know the system should act and what are the variances within that system. If you can do that, you will be very successful in protecting your industrial control systems. And then lastly, my advice is to create value. So starting over here in the top right-hand corner with security value, if you're buying all this armor, you're making all these weapons, and that is creating security value for your industrial control systems. You have to find a way to make that into operational value through your objectives. And when you create security value and operational value, that creates organizational value. And that's how you bring in those heroes on the executive team. That's how you show them the value of what you're doing. And you get that more integrative process within your organization. You may only begin with security value. That may be the place to start. But if you can stretch that into operational and organizational value, you'll continue to enjoy success within your program. Okay, that is my last slide. Hopefully some of that made sense. I think it's very important in the context of you need this deliberate planning and process that Jason laid out. And sometimes you can't get that on day one or day zero. So sometimes you have to begin building it, and hopefully these practical steps can help you if you find yourself in that situation. All right, that's it for me.
Thank you very much. That was great. That was super interesting. And I like very much the way you guys build on each other's presentation and on previous presentations to sort of tie together. I have a couple of questions here. Let me see.
Yeah, I just have to say, Jason, you're doing the hard ones. I'll take the easy ones.
I didn't agree to that at all.
I saw that you answered this question that we had, Jason, thank you. Could you sort of, I can read it out loud to whoever might have missed it on the Q&A or who's joining by telephone and can't see that. And so if you could sort of answer it again, I guess, or summarize your answer or embroider on your answer. it says that I'm a very visual person, so Jason's graphics are amazing. Yes, we agree. Thank you. I think we got the best graphics so far from both of your presentations. Thank you. She says I'm not an IT expert, so my question is coming from an angle of ignorance. Is it possible just to isolate or separate critical feeders, say for example, military, key government agencies, from the integrated system to protect these? I guess this is from the distribution utility viewpoint, unless we're talking about a fully vertically integrated power system.
Yeah, and so in my answer, I stated it really depends on the power system itself. So there are two things I think that we're talking about here. One is, can I isolate one feeder from the rest of the system? That will typically be a no. It depends, I guess, on the national criticality of certain sites. We have the same discussion in the United States about how it is that we have sort of separated out reliable operations for bases that need them, for example. And so in those cases, it depends on the power system. And if the power system, what you'll find is as you stack these things together, there's still going to be one domino sort of up the chain that you can remove and the rest of it will come down. So you typically won't have a dedicated feeder, but again, depends on national interests and a whole bunch of other things. Similar will be true for industrial clients too, right? So you may have industrial customers, a smelting facility or something like that, that really requires dedicated power. And you may have a similar conversation about their power requirements and needs. From a networking perspective, that you have a little bit more control over. So you may be able to isolate it from a communications perspective, have its own dedicated system. If you can't, again, go back to the mantra, detection would be a must. So if you can't separate out and you can't prevent an attacker from being able to sort of daisy chain into that critical system, being able to detect something and then respond appropriately would probably be the next more prudent investment. But two different things, isolation of power system versus isolation of communications.
Thank you very much. I have another question here. In the absence of standards and, oh, I'm sorry, Michael, would you like to, is there anything you want to add to that?
Well, I would add to that. I would just like to remind you that, remember, when you're looking at critical assets, whether they be on the grid or whether they be in your networks, those are what is critical to your business, right? So that's an easy business case to make. If you can identify how critical it is to your system, and maybe you provide a feeder to an Air Force base or some military installation, if you identify that as critical, it gets a different treatment. And so that is about, risk is about your business. It's not all about regulation. And so don't be afraid to go beyond what the regulations say you have to do to say, this is critical to us. What can we do? How can we architect the networks? How can we make engineering changes in the field to treat it like it's critical? I say that all the time. You can't say it's critical and then treat it like it doesn't matter. Those two things have to go together. So don't be afraid to go beyond the regulations. I think that's always a good point to make.
Yes, we're going to, that's a good segue to shout out. We're having a future webinar on that, just on that topic. Sorry, Jason, was there something you wanted to add to that?
No, it's 1,000% agreed. Having just sort of gone through the royals of NERC-CIP, having that conversation is always critical. And I know that Europe is dealing now with the NIS directive. There's a whole lot of regulatory things that are happening worldwide. So that is always a good point.
Yes. And I forgot to mention, most of you are probably seeing our web poll in progress right now. We'd really appreciate it if you would answer. If you cannot see it, if you click on the polling icon at the bottom of your screen, that should bring it up. And now to the next question. In the absence of standards and with understanding for a utility champion has to be honest in the development of a roadmap, there is a risk in the management that the management of the utility will blame IT for any issues that come up out of that analysis. Any advice on how to deliver the message? How would you prioritize the needs or components of the roadmap?
I'll take it.
I have something really quick, and I know you're going to have a more in-depth answer, Jason. So for me, to tie that back, I think the way you deliver those messages is you start with your operational objectives. You say, this is what our operational objective is, and therefore it's important that we do these things. And I think that is the foundation for the conversation.
Yep, I bold, italicized, highlight, underline everything that Michael said. I think that one of the analogies that I give folks, and it's relevant in the United States, but I know also from my power engineering background that worldwide we have this problem with a culture of safety. And so understanding that in the 1970s, we didn't have a good culture of safety in the United States, for example. But then we started having some serious incidents that linemen were losing their lives. And we adopted a culture of safety. And now if you go into any utility in the United States, you get a safety moment before every meeting. There may be a safety intranet page at your utility. Now, what I ask is, do we do the same thing for security? We have now had security incidents that have impacted safety, that have sort of dedicated attacks on safety systems. So when an engineer goes and responds to what looks like a reliability incident, because these things will look like maintenance events, right? They may not be in a safe space. And if you're dedicated to a culture of safety and a culture of reliability, you now need to also embrace a culture of security. They are one and the same. So I always tell people, if you do a safety moment, do you also do a security moment? Do you have a security intranet page just like you have a safety page? Because right now in this new world, we are sort of merged on all those topics together.
Thank you. I have one more question, I believe. Oh, wait, maybe you have another one here. A question about training. Do cybersecurity experts and firms go through a rigid due diligence and rating based on set criteria, either by the industry or government, like an accreditation process? And if so, is there a list of companies that accredit?
So I imagine we're talking about some sort of rating system from the governments themselves or an industry rating. So I think that sort of Michael hit on the head where if you're an ICS security professional, you are gainfully employed forever right now, right? There aren't that many of us who go through our own accreditation, right? So I also work for SANS. I've got many GX certifications as well, where it's an ANSI accredited process that I go through to make sure that I have certain level of subject matter expertise. That's not true across the board. It's definitely not something that is standardized or regulated, but it is something where if you go through additional efforts for that training that Michael was talking about, really investing in your experience in this space, there aren't a lot of us out there. We've only had certifications for ICS security over the past about 10 years, not even 7 years, I think is when the first GX certification came out for that. So this is really a new and nascent field for ICS security, in particular, getting to that professionalism that we see in other areas of risk, like safety.
Could you write those acronyms in the chat that you're using just now? ANSI and ICS and.
Yep.
Great, thank you.
I would note to Jason's point that mostly system certification and accreditation is typically thought of as a government process. But what I think you see in specific regulatory environments, they're trying to force that introspection on utilities. They are asking you to do some of those things yourself by giving you criteria to think about and rank your assets with, and really think about, okay, so if this asset is this level, then what controls do we need to apply? And so I think that there's a burgeoning certification movement inside of utilities themselves that's not being necessarily forced on them from external forces, but we are drawing on years and years of government experience around system certification and accreditation to pick the parts out of that make sense for us and allow us to be agile and apply those concepts to thinking about classes of assets within our utilities that we're operating and trying to protect.
Great, thank you. Thank you. And I have another question here. I really like that you mentioned it needs people to protect the system and not systems to protect the systems. So it looks like the endpoint of the operation is still people. The question is, what do you think is the best place to stay in the flowchart procedure, inside the system logs or in the gateways of the network? I don't
Mike,
understand
you want to tackle that first?
systems to understand the question.
Well, so I'm not going to give a very satisfying answer. My answer would be yes. Those are the two very important places to start. I think with the system automation and the products that are available for a range of costs today, network and device logs is the place to start, because you can get in a very entry-level position with that doesn't cost a lot of money, and you can start to understand the dimensions of the journey that you're about to embark upon. But certainly when you look at zones of security and maybe a zero trust model and how you segment those networks, those gateways where traffic flows in and out are natural places to think about, what's this going in here? What's this coming out here? Back to application data flows and system baseline. So yeah, I think those are both, either of those is a win.
Yeah, and thank you, Michael. I want Michael to go first because I don't want to. We have a product in this space, so I don't want to say, hey, just look at this product. But obviously, the product in the space and the sort of the market you're seeing in ICS security now, focusing on OT specific detection, is there for a reason, right? It scales really well. It allows you to have sort of a more nuanced visibility. And if you find yourself applying IT tools into that OT network, you may break something as a result. So having that OT specific, I think that Michael really hit it on the head when we talked about understanding your protocols and the engineering processes. And so if you sort of have a way to capture that data on that OT network side, you have a scalability of visibility. And then as you start, if something sort of triggers from, if you do anomaly detection or looking for threats, then you can start looking at, well, what type of collection management framework do I have? How can I get data for an individual asset? Because you're not going to be able to have the same level of data for everything, right? Your HMI, your Windows machine is going to have a potentially more host set of logs than you can get than what you may have at a switch, for example, where you're looking at maybe config data. So giving that sort of broad breadth of information that you could get from network analytics and then dive down into host-based as you need to, that could be a good strategy for being able to help you out both from an incident response perspective, as well as just looking for the bad stuff that may happen.
Thank you very much. Another question, in most USAID assistance countries, the power systems were built 30 to 40 years ago. Understanding the need for redesigning the architecture, but with limited funds, can utilities maybe break this redesigning process into phases? And here comes a tricky one. How can a utility trust third parties for the redesign fit?
So that same problem is here in the United States too, right? We don't have greenfield projects in many parts of the United States. Most of them are, and by greenfield, for those who don't sort of understand that phrase, it's a brand new power system that I get to be able to deploy myself. A lot of it is antiquated systems. There are many times where I'm still dealing with non-industry specific protocols, right? Somebody homebrewed something, or I'm dealing with a protocol from 30 or 40 years ago that nobody has support documentation for anymore. I think that it's absolutely critical to be able to do this in phases. You're not going to be able to sort of rip and replace everything. That will never happen. What you can do is start off with sort of the steps that Michael and I have outlined. So understanding that architecture, understanding that visibility, understanding the critical things that you want to protect. And that will help you phase things into what you want your new system to look like. Because you may go after those critical components first. Or if you look at sort of what a project plan could look like, you may say, I actually need to hold off on that right now because I need to make sure that stays reliable. And so I'll focus on another aspect of our system, get more visibility there, understand how to roll out new security in another corporate environment or a less critical environment before going to my critical stuff. All of those strategies are in play, but it's absolutely a phased approach. It's never rip and replace. And that's true for every industrial vertical that I work with, except for some very highfalutin, lots of money ones where maybe they do a rip and replace, but that almost never happens.
Yeah, I would echo what you said 100%, Jason. I think the quickest re-architecture that I've ever worked on inside of an ICS was almost 2 full years. So, I think a staged approach or a phased approach is essentially the only way that sane people can get it done. especially if you're resource constrained.
Any comments on the trust issue? I guess that
Yes.
was an issue here too. No?
Well, and I think in the utility industry, we are seeing the emergence of a group of very trusted partners inside of engineering and vendors, and I think it takes a lot of due diligence on the utilities part to find that trustful partnership. But you know, my approach has been to break it down into foundational components. So if I'm doing an architecture inside of an industrial control system, I'm not always looking for an industrial control company to do that for me. I'm looking for a utility engineering company that has some very good network and telecom background, right, that can bring that discipline to the network side. And then I provide them with the objectives, the security objectives. I mean, this is exactly how we lay out our proposals. Here are the operational objectives. Here are the security objectives. Here are the compliance objectives. And that's how we start that process and that conversation to build that trust and understand that they can do the work that we're requiring them to do. So I think it's absolutely possible, but you have to curate those relationships over a long term if you're inside of the utility industry.
Yeah, and it takes time, and it takes people who have time to do that kind of due diligence. And I guess there's no way to really get around that at all.
Yeah, and it actually dovetails into a conversation that we're having in the United States a lot now around the supply chain. And the supply chain risk that folks talk about from a financial risk perspective is the same thing as a cyber risk perspective. So the things that you may ask companies when they come on board about sort of how they do an engineering approach or the risk that they're taking on to build the system, asking additional questions about what they do for cybersecurity, or to Michael's point of other capabilities they may have that would impact the project, is really critical. Now, that being said, you may not have all the expertise to know what the answers say. In those cases, you'll have to talk to somebody else, but it's an educational perspective. And we now have regulations that are about to be put in place in the United States for supply chain, understanding those cyber risks, having notifications when something goes wrong with a vendor. All of that is now looped into what we're sort of talking about internal in our industry in the United States. But I would expect to see that sort of percolate out and be in other industries soon, because the vendors all need to start addressing that in some way, shape, or form.
Terrific, thank you. Okay, we'll have one last question. If a utility does not know what's on its network, is there a step-by-step guidance? Where do you start? What do you look for? Where can they go to find that kind of guidance?
Well, I think you got some really good portion of it today. You know, first of all, you're not alone, right? Most utilities don't know necessarily what's happening on their networks. Number two, I would say focus on two things: protocol inventory and application data flows within your critical systems. Those are two very good points of advice. And you know, Jason said a lot of things today that go to that exact issue. So I think you've got a lot of good advice today, but Jason's probably more familiar with some very specific standards or guidance out there that could help.
Sure. I think it really comes down to, again, the environment. So one of the solutions could be to deploy sort of one of these monitoring solutions, right? Because it will actually give you a lot of that protocol analysis, tell you what devices are communicating to what. And it could be something that if you have the right level of training to understand what's going on, that you could deploy a technology that can give you data quickly. That being said, if you're in a plant, for example, one of your first things you may do is just a plant walk down of somebody who understands communication equipment and is looking for where the wire is pointed into. Being able to have that walk down, there have been a lot of different sort of field devices out there, substations, generation stations, where we've done walk downs and we've found new devices that would not have been found unless you had some sort of visibility into your system. So some things like that could be a really easy, quick win. And then from there, nobody likes to hear that you're probably going to have an Excel spreadsheet of all this information, but at some point you're going to have an Excel spreadsheet. It's where all good programs start, and it's where all good programs understand it's going to fail. But that's where you start then listing out this information and get more understanding to the point of being able to have a more mature process around it. But it is crawl, walk, run. And maybe your very first step is just talking with engineers, understanding their systems, and then building out your capabilities more organically over time.
Terrific. Thank you very much. Well, I think with that, I'm going to end today's session. Thank you very much, everybody who joined us today. Special thanks, of course, to our wonderful presenters. Everyone will be receiving an email from Jake with a link to where they can rewatch the recording if there's any details they missed, or if they joined late or weren't able to see the presentation, only listen in, please. You will be getting that email from Jake shortly. And thank you all very much, and have a great rest of the week, and stay safe, everybody. Until next week. Bye-bye.
Bye. Thank you.
Thank you.